Hello, I am Matthew Anderson, Manager for High Performance Computing at Idaho National Laboratory, along with expert spectroscopist Ryan Frock, Don Skates, Ed Reber, and Michael Reichenberger. In our homes, highways, and offices, we are surrounded by sources of radiation: candle wicks, bananas, cat litter, ceramic glasses, granite countertops, and sometimes sources that are much more dangerous. Is there an automated and fast way to distinguish between innocuous sources and dangerous sources, and also identify the isotopes present and quantify their activity? Well, you can have a fast answer or an accurate answer, but you can't have both. Until now. Ryan and his colleagues detect and analyze gamma rays from a wide variety of radiological samples. This is a painstaking task requiring thousands of hours each year to perform the analysis. Over the past 15 years, they have created a database of their work costing more than $100 million, which we have leveraged to automate the analysis that an expert human spectroscopist would normally perform. The result is Spock, which stands for the Spectral Observation Convolution Neural Network. It is the equivalent of a human spectroscopist with 20 years of experience on a chip. Spock is small, 6 megabytes, and can run on as little as 1.3 watts, yet it gives 99% accurate analysis with 90% confidence error bars in a fraction of a second. It can be deployed in a field programmable gate array. It has been tested for nearly 2 years, and in July of this year was tested on the International Space Station for over 100 hours. What are the uses of Spock? First, waste management. Many states now require landfills to monitor all incoming waste for radioactivity, even residential trash from the curb. These users have a regulatory requirement to monitor and prohibit the entry of radioactive waste into their locations quickly and accurately without false alarms. Second, air and seaport security. These users also have a regulatory requirement to monitor a huge volume of traffic for radiological sources that may be hidden or difficult to detect. Third, material analysis. These users include environmental and home monitoring systems, as well as medical isotope manufacturers who use gamma spectroscopy for quality control. Fourth, power generation. These users come from the nuclear power industry who use spectroscopy to monitor fuel behavior. Fifth, occupational dosimeters and area monitoring. These users range from hospitals, nuclear power plants, radiation measurement laboratories, and the Department of Defense as part of ensuring nuclear non-proliferation. 6. Manufacturing and radiographic analysis. These users deploy gamma spectroscopy as part of non-destructive testing and manufacturing quality control across a wide range of industries, from nuclear fuel fabrication to weld quality assessment. What are the market problems? Radiation measurement systems in general suffer from two common problems: false positives and long exposure times required for accuracy. Automated analysis techniques that are attached to those radiation measurement systems only exacerbate those problems. So the conventional approach for this is to use an expert human spectroscopist to perform the analysis. This will improve accuracy, but also increase latency. False positives frequently plague radiation measurement. It can be very difficult to distinguish between a large amount of cat litter and a shielded but potentially dangerous radiological sample. Of course, false positives are infinitely preferable to false negatives in the case of radiation measurement. But when a detector gives off so many false alarms, the operator will likely just turn it off and potentially make matters worse. Second, accurate analysis can often require minutes to hours of collection time. This makes accurate radiation analysis difficult for customers who need to scan every container on a container vessel or every truck on the highway. Potential customers for Spock are split into 3 categories: radiation measurement instrument manufacturers. These companies build occupational dosimeters, spectroscopy instruments, and area monitoring instruments. Nuclear power companies. These companies already have procured instruments and perform regular spectroscopy analysis using expert human spectroscopists for compliance. And government. These government agencies have mandates to monitor for radiation in the environment: highways, airports, and shipping ports. These customers generally have a third party execute the spectroscopy analysis at infrequent intervals. However, they already have procured radiation measurement instruments that can be interfaced with Spock. Why do they need Spock? Simply put, a radiation measurement is worthless without expert analysis of that measurement. For example, the state of New York deploys direct gamma radiation monitoring in multiple locations around the state, but only analyzes the data once every quarter, thereby reducing the effectiveness of the monitoring. By using Spock, customers gain access to instant and automatic expert radiation analysis, leveraging over 15 years of expert human analysis costing over $100 million. What is the value proposition? The key value proposition is this. Spock provides automated radiation spectroscopy analysis with accuracy equivalent to a human spectroscopist with 20 years experience. Spock has some secondary value propositions, including the fact that it is very low power, can be radiation hardened, is trained against a broad isotope library, and does not require a long acquisition time for input. What about the competition? Existing competitor tools are based on automated curve fitting, where an attempt at an automated fit is made for each peak in a spectrum. An expert spectroscopist is able to properly identify the background and make a more accurate fit for each peak in the spectrum, resulting in a significant improvement in analysis accuracy. Spock is trained entirely using expert spectroscopy analysis and does not employ any automated curve fitting approaches. This results in a substantial improvement in accuracy for analysis. The market segment for automated and accurate radiation analysis is enormous. Here are some of the largest markets for Spock. The most immediate market space is in the radiation detection and measurement space, homeland security, occupational dosimeters, and medical isotope fabrication. The business model centers on the key value proposition. Spock is an automated analysis tool that is fast and accurate, with multiple customer segments spread across the radiation measurement space. As the isotope analysis database continues to expand, subscription updates to Spock will complement the revenue stream. The Spock team as a whole has more than 60 years experience with radiation spectroscopy and 10 years of artificial intelligence experience. The team is actively entering non-disclosure agreements with radiation measurement manufacturers to explore the integration of Spock with existing commercial products. What's next? Spock will go through a second round of testing on the International Space Station in the next 2 to 3 months. We estimate that a company adopting Spock would need about $1 million to bring Spock to market in field programmable gate array form.